Now, how to represent a chemical change? Now, a chemical reaction has taken place and the starting material and the end product are not the same. For example, we may have hydrogen taking up oxygen to become water. So, water is going to be definitely different from hydrogen and oxygen. Hydrogen and oxygen are gases, whereas water is a liquid. So, there is a change in the substance. The substance has changed. So, there is a change in the molecular composition, there is a change in the structure. Now, this is how we represent a chemical reaction. Means this side, that is on the left hand side, we have what is called reactant or reactants in this case, and on the right hand side we have got the products. So, the initial set of species which is undergoing a chemical reaction is called a reactant, and the one which is formed at the end of the reaction is called the product. Now, in any such reaction, any chemical reaction, we always look for conservation of mass. When you have conservation of mass, the atoms on this side and atoms on that side should be same in number. You cannot have loss or gain of atoms. So, there is a law of conservation of mass. So, with this conservation, what we have to account for is the number of atoms on the left hand side and the atoms on the right hand side. Now, look at this reaction. There are 2 hydrogen atoms and 2 oxygen atoms, whereas here there are 2 hydrogen atoms no doubt, but there is only 1 oxygen atom. So, this reaction we say is not a balanced one. So, we have to balance the reaction. So, in a reaction we have the species which are going to react called the reactants and the species which is going to form at the end called the product, and between the reactants and products there is a conservation of mass and all the atoms should be accounted. So, there should be an account of atoms. If you have 4 hydrogen atoms on the left hand side, you need to have 4 also on the right hand side. So, that way we should have a balance of atoms. So, balance of atoms is going to balance the reaction. So, this is what I have written called the skeletal equation. Skeletal equation means what species is turning into what species, but not yet balanced one. So, this skeletal equation is simply going to tell us what are the reactants and what are the products. But how to balance the reaction, that we are going to see now, taking a few examples. Now, balancing of reaction has to be done because we have to go according to the conservation of mass and all the atoms have to be brought into account. So, in this method of doing the balancing of reaction, we follow these 2 steps. The first step says that the element appearing least number of times, both sides, that is reactant and product, is going to be balanced first. Next is when the frequency of occurrence is same, suppose the same element is or any 2 elements are having same number of occurrences. For example, 2 here, 2 there for both the cases. Let us say there is A 2 on both sides, B 2 on both sides, then we have to balance the metal first. The metal will be balanced first. Now, taking these 2 steps will balance this reaction. This is the skeletal equation that I have put, that is magnesium plus oxygen is going to give magnesium oxide. Now, look at the reactants and the products. Magnesium is 1 here, 1 there. So, I put here 1, 1, means magnesium is 1 in the reactant, 1 in the product. How about oxygen? 2 in the reactant and 1 in the product. So, magnesium is already balanced. So, we will have to balance now oxygen. Now, that oxygen is balanced by making it 2 here, because this 2 is having a 1 here. So, I will make this 2, means in the product I have to make oxygen 2. So, I have made it. But in doing so, what happened? Magnesium became 2 here in the product and 1 here in the reactant. Therefore, we will have to balance the magnesium. So, that magnesium is balanced by this is 2 and this is 1. So, this 1 that is in the reactant, you have to make it 2. We have made it 2. So, now look at the reaction. There are 2 magnesiums and 2 oxygens, also 2 magnesiums and 2 oxygens. So, the atoms are accounted. So, that way we have the balance of the reaction. So, what we find is that we have to look at these 2 steps. Probably the first step is not used up here because magnesium is already 1 on both the sides. Element appearing least number of times is balanced first, but it is already balanced here, so we'll have to go for balance of oxygen. We'll see few more examples and then make the rule easier to understand and then easier to apply. Now, this reaction is potassium chlorate turning into potassium chloride and oxygen. This is itself a method of preparation of oxygen. So, oxygen is prepared by decomposing KClO3. Now, look at the reactant and product numbers of atoms. So, K is 1 in the reactant, also 1 in the product. Cl is 1 in the reactant, also 1 in the product. So, we need not balance now K and Cl. So, the present balance is only for oxygen. So, how many oxygens are there on the reactant side? 3 it is, and here it is 2. So, how to balance? LCM. Now, this will be LCM 6. So, I will have a 2 here and a 3 there. Would this balance the oxygens? Now, how many oxygens are there? 6 and 6. So, oxygens are already balanced here, 6 and 6. How about potassiums? Potassiums are how many? 2 here and only 1 there. Chlorines, 2 here and 1 there. Now, we will have to balance potassium and chlorine. Between potassium and chlorine, potassium will get more priority because there is a metal. But look at this. If I have to make this 2 KClO3 balanced on both the sides, that 3O2 is there. If I put a 2 KCl, it would be useful for both potassium and chlorine, is it not? The potassium is also made 2, chlorine is also made 2, and both are 2 on the reactant side. So, with just one step, we are going to have both potassium and chlorine balanced on both the sides. So, that way we have now what is the new set? K, Cl, oxygen. Oxygen is already balanced at 6. Chlorine and potassium are both made 2. So, this is the balanced reaction. Look at this. There are 2 potassiums, 2 chlorines, 6 oxygens. 2 potassiums, 2 chlorines, 6 oxygens. So, equation is completely balanced. We will see one more case. Now, this reaction is between ferric hydroxide and sulfuric acid. Now, I have put here the number of times Fe comes in the reactant and in the product. In the reactant, Fe is only 1, but in the product it is 2. Hydrogen, 3 plus 2 is 5, and then on the product only 2. Oxygens, 3 plus 4 is 7. In the product, 4 into 3 is 12 plus 1 is 13. And then sulfurs, there is only 1 sulfur here and there are 3 sulfurs here. Now, the first thing that you will have to balance is Fe because it is lesser number, 1 and 2 only, whereas sulfur is 1 and 3, hydrogen is 5 and 2, and then oxygen is 7 and 13. So, what we will do is we will simply put 2 here. So, is the Fe balanced on both the sides? So, now 2 here and a 2 here. Next thing is we are going to balance the sulfurs because it is 1 and 3. Now, to balance the sulfurs, I will simply put a 3 here because 3 sulfurs would match. So, this will be 3 and 3. Next thing that you will have to look at is the hydrogen part because hydrogen is the lesser one now. So, 5 and 2 there. So, this is how many? 3 into 2 is 6. 6 plus 6 is 12, is it not? 3 hydrogens into 2 is 6 plus 2 into 3 is 6. So, I will simply put a 6 here. So, 12 hydrogens, 12 hydrogens. So, I will put here 12 and a 12. Look at the oxygens. Are the oxygens also balanced automatically? Look at the oxygens now. 3 into 2 is 6. 6 plus 12 is 18. 12 plus 6 is also 18. So, 18, 18. So, that is how you balance a reaction by first looking at the species which is less in quantity on both the sides balance it and then balance according to sequence the ones which are lesser to higher. So, that way we have this done first after Fe, then hydrogen, then finally oxygen. We found that oxygen is already balanced because there is no other species present to balance. So, that way we have the balancing of reactions done.